Imagine stepping into a different world without leaving the comfort of your living room or seeing your favorite video game characters come to life right in front of your eyes. These are the promises of virtual reality and augmented reality. Virtual reality, or VR, immerses you in a digital world. It's like diving into a pool. But instead of water, you're surrounded by pixels and data that create a new reality. A VR headset transports you into a computer-generated environment, making the unreal feel real. On the other hand, augmented reality, or AR, brings the digital world into our own. It's like having a layer of fantasy overlaid on your everyday life. With AR, you might see a dragon flying over your city skyline, or a recipe projected onto your kitchen counter. The real and the digital coexist, augmenting the way we perceive our world. Now imagine combining the immersive nature of VR with the overlaying capabilities of AR. This is where spatial computing comes in. Instead of interacting with a two-dimensional screen, spatial computing allows us to interact with digital objects in the same way we interact with physical ones. It's like the computer understands our real-world space and can integrate digital elements into it. The story of spatial computing begins in the early 2000s, with researchers exploring ways to make computing more intuitive and immersive. The first major leap came in 2007, with the introduction of smartphones equipped with GPS and accelerometers. These sensors enabled the devices to understand their position in space, laying the groundwork for spatial computing. Fast forward to 2010, when Microsoft introduced the Kinect for Xbox 360, a motion-sensing device that used cameras and infrared sensors to track the player's movement in a 3D space. This was another significant milestone in spatial computing. In 2016, the world saw a massive surge in AR popularity with the launch of Pokémon Go. The game used spatial computing to overlay digital creatures onto the real world, as viewed through a smartphone. The integration of spatial computing with VR and AR has only intensified since then. Today we have VR headsets that not only transport us to different realities, but also understand our physical space, allowing us to interact with digital objects as if they were real. So what's the takeaway here? Virtual reality immerses us in digital worlds, augmented reality overlays the digital onto our reality, and spatial computing makes the interaction between these two worlds seamless. These technologies are reshaping our world, blurring the line between the digital and the physical, and transforming the way we interact with technology. The future is here, and it's more immersive than ever.